This is Physical Chemistry, Part 1, Thermodynamics, Chapter 10, Electrolyte Solutions, Section 10.1, the enthalpy, entropy, and Gibbs energy of ion formation in solutions. We need to choose some zero references first. The standard Gibbs energy of formation of solvated H plus or protons is chosen to be zero at all temperatures by convention. So this is the arbitrarily chosen zero references. We can use this information to calculate the value of entropy of the solvated protons in a standard state. This is because dG equals negative S dt plus VdP. When pressure is constant, VdP is zero. dG is negative S dt. And the entropy is simply negative dG over dt. So we use this equation to get the entropy of formation for the solvated protons in the standard state. It turns out this delta G of formation is chosen to be zero at all temperatures. So the temperature dependence is zero. Therefore, the entropy of formation of the solvated protons in the standard state is zero at all temperatures. And we define the molar entropy of the solvated protons to be the entropy of formation. To get the enthalpy of formation, H equals G plus Ts. At any temperature, we have delta H equals delta G plus T delta S, and delta G is zero, delta S is zero, therefore delta H of formation, the enthalpy of formation of the solvated protons in the standard state is zero at all temperatures. So in summary, the Gibbs energy of formation, the enthalpy of formation, the molar entropy of the protons, the solvated protons in their standard state are used as the zero references. With the zero references, we can determine the enthalpy, entropy, and Gibbs energy of formation for some anions, such as chlorine minus at all temperature. How? We need to design a chemical reaction that involves both H plus and chlorine minus. So this is example, if we dissolve HCl gas in water, we create H plus and chlorine minus in water. Suppose we can measure the equilibrium constant, and then we can determine the Gibbs energy of the reaction in a standard state. Given that we use this equation for the Gibbs energy of reaction, really it's just the products minus the reactants. This is because Gibbs energy is a state function. And then we have this Gibbs energy of formation for chlorine is simply this delta G of reaction plus delta G of HCl and that of water. The reason is over here this part is zero. We define this to be zero. The Gibbs energy of formation of solvated protons in their standard state is zero. And then in this case we can determine this Gibbs energy of chlorine minus at one temperature and another at another. So if we have enough data for a decent temperature range, and then we can compute the molar entropy of chlorine minus given the temperature dependence of the Gibbs energy of formation for chlorine. Once Gibbs energy and entropy are obtained, it's really easy to get the enthalpy of formation. Again, this is because H is G plus Ts. Therefore, this enthalpy of formation is Gibbs energy of formation plus T times the entropy of formation, or this is simply molar entropy, same thing, at the given temperature. If we get the Gibbs energy, entropy, and enthalpy for chlorine minus, we can now deal with sodium plus or other cations. Why? Now we design another chemical reaction that involves sodium plus and chlorine minus, we use the same algorithm. And this time, we have this Gibbs energy of reaction is equal to, again, products, sodium plus and chlorine minus the reactants. Sodium chloride solid and water, they are the reactants. This way, we can determine the Gibbs energy of sodium plus in water at any given temperature. And then if we measure this at different temperatures and look at the temperature dependence of the Gibbs energy of formation, we get the entropy of sodium plus. Finally, we determine the enthalpy of formation for sodium plus. Now, if you have chlorine minus, sodium plus, H plus, you know how to compute. Or, we need to design experiments, carry out the experiments, measure the equilibrium constant, calculate the Gibbs energy of reaction. But theoretically, you know how to get the Gibbs energy, enthalpy, and entropy for any other solvated ions.